and as fall proceed, when we get closer to fall. So we're back meeting every second Thursday of the month. We're still on Zoom, obviously, until further notice. So I just have a couple of things to, some business, Northwest Cook County Group business to get through, and then we'll get to our presentation, which was I'm really looking forward to. First, as you can get involved, we have, definitely have some committees, and if you go to this page, there's all various ways you can get involved. I'm just putting the link in the chat right now. You can also go to our homepage, and which has our calendar, and you can keep up with current events. We're pretty good at keeping up with that, including tonight's presentation, our program meeting. And so here's our, here's our homepage. But also, if you're not a member, you can join. Click on the join button, and then there's also you can get on our email list if you're not on, which includes receiving the newsletter. And if you go to the calendar page, you can also see that on September 24th, the ISEA has a solar tour, and you could register for that event at this link I'm just about to put up. Now with CEJA passed and everything, solar is going to be much more omnipresent. That's what we want. That's the goal. Does anybody from one of our committees have anything that they would like to add?
Nope.
Also, it's election season. There's a lot going on with that regarding that. So check your ballots. There's a couple of referendums that are very important, and also the candidates that the Sierra Club has endorsed as well. And of course, all that information, you can get the most current information if you sign up for our email updates. If no one has anything else to add, I'd like to get to our presenter, and Pat is going to introduce Liz for us. Pat?
Hi, everyone. Well, I'm delighted to welcome Liz as a fellow educator and somebody interested in communicating science. She's has done an awesome job so far. She's the outreach program manager for the School of Freshwater Sciences at the University of Wisconsin-Milwaukee. And Liz has spent her career working to inspire and engage young people. She's had various roles as education coordinator. She actually developed a formal outreach department within the School of Freshwater Sciences there. And she's a liaison between scientific researchers and the Great Lakes community, because she's able to share her passion for the natural world by communicating scientific findings and striving to make water science meaningful to our daily lives. And I think that's something that science needs, is a good interpreter. So I'm thrilled to have Liz talk with us. So the format will be, if you want to ask a question during her presentation, just click on the reaction button at the bottom of your screen and you can raise your hand. Otherwise, you can put questions in the chat, and then at the end we can talk about that. So go ahead, Liz. Thank you. Oh, and the program is being recorded too.
Thank you for inviting me, Pat, and everyone else. I'm really excited to talk with you all. I will say I am going to share some slides, but I don't know if you happen to notice right as we got started, I'm in one of our rooms at school and there's not enough movement. So if my lights go out, I just have to stand up and move around a little bit because, that's what happens when you're in a building that's empty at this point. So I'm really looking forward to talking with you. And yes, feel free to ask questions or anything. We have some people monitoring. Thank you. Just in case I don't see you. Sometimes I get kind of involved in my presentation and don't always see, but I'm happy to be here. So there we go. All right, so you should all be able to see now the start of my presentation. This is our research vessel, our current research vessel, the Niske. And I'm really fortunate to be able to go out and take groups on there at times. But really, we're so fortunate where we are located is right on Lake Michigan. We are an oceanographic style research institute on the Great Lakes. And the building you see down kind of towards the bottom, right, that long building, that's us. And what really makes us an oceanographic style research institution is that we are right on the water. There are certainly other research organizations and academic research organizations on the Great Lakes, but we're one of the few who are really right here. And we're the first school in North America dedicated to freshwater, and the largest academic research institute on the Great Lakes. And, we've been doing this work for quite a while. In the 60s, we began as the Center for Great Lakes Studies, and that was located on the main UW-Milwaukee campus. And we were kind of a research unit that was functioning within another school. And then we had the opportunity to move down to the harbor, and that was in the early 70s, and we were very excited to have that opportunity. We moved down here, had a name change. We are the Great Lakes Water Institute for quite a while. And we're doing all of our great research, had wonderful students working in all of our labs, and really decided it was time to become a school. And in 2009, we became the School of Freshwater Sciences, which means that instead of our students getting a degree in biology from UWM or somewhere else, we were able to provide that degree directly from freshwater sciences. And we started with master's and PhD programs. In 2014, we kind of added a whole section to our building. And then we've had some fun new updates, which I'll talk about kind of at the end. But really at the core of all of it, our mission has always been research and education. Checking what is going on in the Great Lakes. And we have 4 areas that we research: freshwater system dynamics, which is really what you would expect us to do. What's going on in Lake Michigan, the other Great Lakes, the rivers in the area. Really, we study freshwater all around the world. We've had researchers at Lake Baikal in Russia, Lake Malawi in Africa, Yellowstone Lake, Lake Bacalar, which is in Mexico. So all of these different places, we're looking at what's going on in those systems. We also look at the interconnection between ecosystems and health. So there are a lot of public health issues that we talk about, from drinking water or pharmaceuticals, or how is the health of our ecosystems kind of affecting our health, that kind of connection. We do a lot of work with freshwater technologies, whether it may be developing new scientific equipment for other researchers to use, or brand new ways of doing aquaculture or gathering data. So that kind of focuses on a lot of that area. And then we're the Center for Water Policy for the state of Wisconsin. That's one of our newest areas. And it really stemmed from the concern we can have all kinds of wonderful data and science and information, but if we can't share that with people or make it relevant, whether it's through legislation or connection to the economy or any of those other things, it's kind of just information. So we wanted to make sure that we can help people make decisions about what to do with their water using the science that we have. So we can provide that data to help make decisions. And so that's kind of the 4 main areas of research that we have. Our students are working on that. Our graduate program, which is our longest program, we have better than 95% placement, job placement once they graduate. And we really do have a lot of alumni working out in the field. I just attended a conference. I was at a conference for a better part of today and ran into 5 or 6 of our alumni at a conference that had 100 people. And that was just ones I happened to run across. So our students are out doing lots of great work, which is always exciting for us. And I'll go through in depth with some more of our research through some highlighted projects. Okay. And I'm going to share those for a little bit, and then maybe I'll pause so we can see if we have some questions. But we are a small but mighty group. We do not have a really large program. Our students, we have about 80 students a semester total. And we have about 20 faculty positions and scientists. So it's a small program. But we have a lot of work going on. So when I'm talking about highlighted projects, it's really a small portion of the different things we have going on. So first, we're going to talk a little bit about some work we do in the human kind of health connection, and that's bacterial source tracking. One of the main beaches in Milwaukee that a lot of people like to go and enjoy, you can see a picture there, Bradford Beach. About 15 years ago, it was closed really regularly because of E. coli. And while E. coli is a good indicator, it's not super informative. So E. coli is just saying there's fecal bacteria present, but it doesn't tell you whether that bacteria was coming from a human or a dog or a bird or a cow. Dr. McClellan's lab can use bacterial DNA to track exactly what animal is providing that bacteria for the E. coli. So using that information, they're able to really come up with smart solutions. So in the water, there was a lot of E. coli, and people in our community all thought it was human bacteria, something going on with our sewage system or water treatment facility. When she went and tested that water, she found very little human bacteria. It was really bird bacteria. So birds would come, grab a snack from someone at the beach, and leave something behind in the water. When the park department learned that, they came up with a really simple solution. They now hire people to walk their dogs back and forth along the beach. It scares the birds away, and the water is open now for people to swim in. So finding that information and that data really helps us understand how to make some smart solutions. If we would have treated it as a human bacteria problem, we would have spent a lot more money than what we did hiring people for the last 15 years to walk their dogs. We would have spent a lot more money and not actually solve the problem. So by having that data, we can find a better answer to what's going on. There are definitely lots of different contaminants that can get into water. We have a number of tracking where we are looking at either gathering samples of water just from the rivers, our local rivers, from the wastewater reclamation facility we have here, or Dr. Rebecca Clapper, who's in the bottom left, she has done work looking at pharmaceuticals in our water, and she has collected samples of water from across the country in various cities, and she can actually predict kind of the health of the people living in that area. Because whenever you take a pharmaceutical, if you have strep throat and you need an antibiotic. You can take that antibiotic the exact way that you're supposed to, but if when you take that, your body doesn't use all of those chemicals. So some of it goes out in your waste stream. So we can look and we can see, if you look at the list, metformin is a diabetic medication. Many people rely on that. Caffeine, many of us rely on that as well. So, you can see some of those things that are showing up in the water. Now, that doesn't mean someone shouldn't be taking the medications that they need. It is a matter of, first of all, disposing of it properly, but second, really trying to follow the other side after it goes through a water treatment facility. It used to be, and I very much remember, the best practice was that if you didn't use all of your medication, you were supposed to flush it down the toilet. Well, that was flushing it right into all of our water systems. So that is definitely a no-no now. In our area and much of the country, a lot of police stations have places where you can drop off medication that you're no longer using, as well as a lot of pharmacies and drugstores like Walgreens and CVS and stuff like that. So, just knowing the information helps us figure out how to best solve those issues. As I mentioned, we do a lot of work with aquaculture and fish nutrition. If you have lived somewhat in the area, you know yellow perch is a very popular fish. In our area, it's the preferred fish for a Friday night fish fry. But our perch populations really declined after some invasive species came through. And so we are working on some of the techniques to bring back populations of fish and really provide an opportunity for fish farming. There used to be large commercial fisheries in Lake Michigan and much of the Great Lakes. Because those died off, we need to start looking at alternative ways. And one of these ways is working in bringing the water into a facility like this. The fish can live in the same water their entire lives, but they can be raised here in a facility, and they can be farmed just like anywhere else. So we aren't personally doing it for like human consumption. We're developing the techniques to do that, but to make it a viable career. In the United States, 80 to 90% of our fish and seafood are imported from other countries. We, believe that we should be able to do more of that here, because we can do it very sustainably in a lot of different situations. So we're looking to do those types of things and developing the techniques, whether that is making sure the fish have exactly the nutrition they need, or really helping them get all of the best practice for how they need to live. So I kind of touched on it, but invasive species are a huge issue in the Great Lakes. There are over 180 different ones at this point, and there have been many throughout the years. Many people know about the sea lamprey, which was one that kind of came in the 1950s, or the alewives. In our area, we had many die-offs of alewives. Well, in like the 60s, there were huge numbers of die-offs where we would have dead fish for 6 feet along all our beaches, and we'd have bulldozers and dump trucks to remove them. This summer this early spring summer, we had a large number of die-offs as well. Alewives are a fish from the Atlantic Ocean, and they, although they can live in freshwater, their systems aren't quite as adaptive to things. So when we had huge temperature changes, you know, we'd go from 90 degrees one day to 60 degrees the next and back and forth in the spring. Their systems just can't deal with that. So they do tend to die off in large numbers in a spring like that. Brown gobies are an issue. There are so many different ones that we can talk about, but the biggest one that has completely changed the way that Lake Michigan functions are Dracynid mussels. And they're kind of the ones just to the right of the text. Those ones in particular are quagga mussels. Zebra mussels were the first ones that came in the late 80s. And by the late 90s, they were in full force, and quagga mussels have actually kind of outcompeted these zebra mussels. So in along the shoreline, you'll still find some zebra mussels, but quagga mussels have really taken over Lake Michigan. If you walked from here to the Michigan coast, you'd pretty much walk the entire way on quagga mussel shells. There's an estimated 900 trillion in the lake. Each one of those shells, those little itty bitty fish, or I'm sorry, those little itty bitty mussels, filter about 1 liter of water a day. So if you think of a liter of anything, 1 liter of water, they can filter through all of that, and they're looking for plankton. So that's what they eat. So they filter through that plankton, and then what they don't want, they kind of spit out next to them. They can't, there are so many of them, they can filter through all of Lake Michigan, all of the water in Lake Michigan in about 2 to 3 weeks. That's why they've had such an impact. They make up about 90% of the biomass in Lake Michigan right now. So you have this huge number of mussels, and prior to their arrival, we had Lake Michigan was kind of murky looking, kind of cloudy looking. That was the healthy traditional way that the lake had worked for more than 10,000 years. Since they arrived, and remember I said it was in like the 90s is when they really took hold. Since that time, they have completely changed the way the lake functions, and they've really cleared the water column. And you can tell this because when you go and look out on the lake and it's a nice sunny day, it almost looks like a Caribbean blue. That's not the traditional, I guess, status of the lake. It shouldn't really look that color. It will now, and it will continue to do that, but it's not really, it's great if you like to dive because you can see long distances in the water, but not so great if you want to eat anything in the water and you're a fish. And that's what we've seen happen. So you can kind of see here, as the mussels gained in their popularity and density, we had a group of amphipods. So they are small zooplankton living in the water. You can see a really blown up one. Their numbers all declined. And that really makes a big difference. That's kind of the bottom of the food chain for the Great Lakes. So seeing that change has really, even though we have 2 people who focus, or 2 of our researchers really focus on what's going on with the mussels, it really impacts all of the work that our researchers do. And this is kind of a video of a sled being pulled along the bottom. all of those little bumps you see that kind of look like little racks, those are the mussels. So before I go off to Green Bay and talk a little bit, are there any questions?
So there's a question in the chat from Jim asking about the testing for pharmaceuticals. Is it done after water treatment within the ecosystems? Is there a difference?
We do it generally within the ecosystem to try and see, but we also work with our local sewerage district to try and look at the outflow after it goes through. And we work closely with them to try and help them work on the methods to get rid of it before it goes. So in our system, you know, our water comes in from Lake Michigan, we use it in our homes, and then it goes back out to Lake Michigan. So we are always trying to make sure we kind of keep that moving and as clean as possible. Unfortunately, for the water treatment facility, it is usually a game of catch up, right? So they don't always know exactly what to look for until we go, oh, did you know this was coming through? And they go, oh, we'll try and figure out a way to stop that from coming through.
And I had a question about whether you had any info about the latest about stopping Asian carp.
I figured you guys might ask that question. Sorry, gotta move. So we, oh man. Oh, the joys of being in a school. So we have looked at this question quite a bit. Some of our researchers have, and you are certainly in more danger of those things happening in the Chicago area because they're coming up through the Mississippi River and into the other rivers. They would say that it's a bit of a red herring. We spend a lot of money, in particular, those of you in that area spend even more than we do, trying to keep the Asian carp out. And I should say, all carp are really from Asia, and there aren't native carp in our area.
Liz, I just want to stop a second, just in case anybody on the call might not know. Asian carp are the newest quagga mussel, or the latest concern about quagga mussels in terms of their, not filtering, but in terms of their eating. So go ahead.
Mm-hmm. So, and they are a big concern, and they are the ones in particular. So all carp are from Asia. The ones in particular most people are worried about are the silver carp. And those are the ones when you see video in a river and they're like jumping out and hitting people in their boats and stuff. Those are silver carp. And silver carp, or really all carp, are really river fish. They like shallow, fast moving water. And that's not really Lake Michigan. So one of our research, our fisheries person in particular, and I even clarified because we were just having this discussion, you know, he doesn't think there's really a reason why they would want to come into Lake Michigan, because it's very cold water, it's moving slowly, and there's not a lot of food for silver carp in the area because the mussels have taken away a lot of the food and stuff that they eat. So it would be like, okay, all of you come to my house for dinner, ignore that wonderful place across the street that has everything you want. Come to my house. You're not going to have a place to sit. I'm not going to give you any food, and I'm going to play really loud music so you don't want to be there. But, you know, come to my house instead of going to that place, which is really wonderful to go. Now, while that is true, he wouldn't expect a big invasion of Lake Michigan. That doesn't mean that, and there's more research coming out, that there couldn't be small parts or individual fish that kind of break through the barriers and then come up and go into, rivers one way or the other, swim along the coast. So while they may not ever be successful in Lake Michigan, that doesn't mean they couldn't expand to other locations and cause issues. Which is really why there's a lot of efforts to try and to stop them and to start looking at them a little differently. One of the issues with like the mussels is that they are really quick reproducers, and they're really hard to get rid of. They're not you couldn't eat them. Those mussels are about the size of your thumbnail. They're really small. And because they're filtering all that water, anything that's pollution or toxin in the water is going to concentrate in their system. Because I've got a lot of people who've asked me, well, why can't we eat them? That's the reason why. However, many people do eat lots of different forms of carp. So there are more and more people who are considering, like, maybe we can start, that's part of a management system where we can start using them for food. So it is definitely an interesting problem though. And I know it's a very big concern, not just in Northern Illinois, Chicago area. I was doing a virtual presentation like this a while ago, and someone was talking about they're from Tennessee, and they are very concerned about them coming from, the Mississippi River is the watershed for the Mississippi River is most of the country. So any of those other areas in Wisconsin could certainly be an issue. So there's something we need to pay attention to. Yeah. So one of kind of shifting back, unless you have other.
There is one other question.
Okay.
Do you have any information on the particulates in the water and to the extent that they have been increasing or decreasing? The release of wastewater from the Whiting BP plant and its implications come to mind.
It kind of depends on the system and what the particulates are going in. There is lots of really good data and information. I'm trying to think of the best spot to find it. Even in your local riverkeeper organizations or sewerage districts, those types of things, they all do report cards. And those report cards generally indicate a lot of that information. But it's kind of hard for me to answer that in kind of a bigger scale because it really depends on so many different things. Like in the Green Bay area, even though it's connected to Lake Michigan, they're dealing with a lot of different things. Even in the Milwaukee area, we have like 3 really popular beaches. Each one is dealing with a different pollution issue or particulate issue because of the land around them, what the activity is, whether or not they're behind a break wall. So if you're really concerned about your general areas, I would encourage you to look in a lot of your city information, and municipalities, your water areas. And also just in general as a good overview, the Alliance for the Great Lakes has a lot of good information as well. So I'm sorry, I know that wasn't the best answer for you, but it's kind of each area can be so different. So in the Green Bay area, a lot of issues that are happening really revolve around the farming practices that have been going on for a very long time. All of, or a large portion of the northern part of Wisconsin, it all kind of filters into one river that goes out, called the Fox River, that goes out through Green Bay. And when you're adding all of these extra nutrients, so if you think about what you want to put on, if you have a garden or something like that, you want to make sure there's lots of good nutrients and fertilizer and all of those things so your plants grow really well. Well, that's what's happening. They have wanted to do that for all of their crops. And this is getting better, just like many other things. But when you add many, many nutrients into a system, it kind of overloads the system and you end up with dead zones. And Green Bay is small enough and kind of changes enough season to season that we will see them come and go. And what a dead zone really means is that there's no dissolved oxygen in the water. In order for fish and all of the other, aquatic life in the water, they all need varying degrees of dissolved oxygen. When that oxygen is not available, just like if oxygen was not available in this room, the animals can die off, and that's why it's called a dead zone. A lot of work has been done in helping to communicate with all the different farmers to talk about best practices for what they're doing to their land and how it goes into the water. There's a lot of monitoring that's going on. Our former dean, Val Klump, oversaw a lot of this monitoring for 40 years, was looking at it and working with the areas around Green Bay, the city of Green Bay and the Bay, to really try and to slow those down and kind of shift them around. There has been some success, but it's always a changing system, and in the Great Lakes, all of these issues, we can't act in a vacuum. We have the water and we want to take care of it for sure, because we use it as drinking water for all of these different things. But that doesn't mean that no farming is going to happen in the area, or no shipping, or any of those other things that are a big part of our economy. If you took the basin, so where all the water in the watershed flows to the Great Lakes, if you took the Great Lakes basin and made it its own economy, it'd be the 4th largest economy in the world. That's because of all the wonderful water we have. So you can't hold off all of those other things without having a variety of impacts. And so you're trying to always play that balancing game between what are the impacts that we're kind of willing to deal with versus the economic impacts versus the environmental impacts. So the dead zones are a really interesting thing. And Green Bay itself is really kind of a good testing ground in a way for a lot of other things going on in the Great Lakes. So you kind of have a smaller place where you can try out new techniques to help make improvements in the environmental efforts. And you can see the effects pretty quickly because it's a smaller system. And some of the ways that we do that, and some of what we're looking at, we are part of a buoy and lake monitoring system with NOAA. And so we put our buoys out in the lake. In fact, they were having some difficulties, so they just went out really recently, or the last ones just went out recently. And they will stay out until about November. Generally, they're out from April to about November. And they are monitoring things. So at the buoy, you're getting 24 hours a day, 7 days a week. You can see in the picture, they have solar on top, so they can gather all kinds of information and data for us. This again is Val Klump is the gentleman I mentioned before in Green Bay. Dr. Harvey Bootsma is also one of the lead scientists on this project. So all of the information that we are gathering through this buoy system is not just coming to us. It is part of the larger national system, the Great Lakes Observing System. So you can see all of those little dots. Those are different parts of the GLOSS network. And it's really trying to track what's going on. We have one very close here by us. And because I was curious to see yours, I kind of narrowed down, and I do have that information. But first I have this slide. Why would we want to monitor? Well, in Green Bay, there is an area of concern, which is a designation from the Environmental Protection Area Agency. And a lot of different waterways may have that. So in particular, the one in Green Bay is monitoring the AOC. It helps us do some modeling, look at those long-term trends, because we can get data when we go out, but we're located way down in Milwaukee. It's a 2-hour drive up to Green Bay. So we're not up there all the time. So it can help us understand that as we're going on. And it helps us provide a lot of really good information. So there's weather forecasting that happens, a lot of recreational stuff, boating, fishing, all that information. And then of course, beach hazards. When you get, like on my cell phone, I will get a beach hazard warning or alert through my weather app. That's through buoy systems like this that we get that information. It's really helping us know what the waves are and that type of thing. So if you go to, and this is part of that GLOSS, that Great Lakes Observing System, there's a section on that website called Seagull. And this is what it shows up when you first see it. So I kind of drilled down because I was curious where your nearest one might be. And these, by the way, the different colors, that's temperature. So it's much warmer temperature in the Chicago area than it is in like Lake Superior, the water temperature. But as we kind of drill down, and there's the website that you can find out this information. And when you go to the website, you can click on any of these areas and you can find out exactly what's going on. So when I went, I clicked on this one right by Evanston, and it is Wilmette, and I'm sorry if I mispronounced something, buoy. And you can kind of see right where it is. And then this is the information that it tells you, what the air temperature is, dew point, wave pattern, and how high the waves are. Then when you hit, there's an area where you can hit deep dive, and you can go down all the way to, I believe it was 35 feet. And you can look at the water temperature the entire way down. If there's current information, like wave or current patterns in the water, it may have that information. So any of these you can click on and find a lot of good data and information about what's going on in our area. And this one has a webcam on it as well, so you'd be able to see that. In our area, a lot of people who fish use this information. People who boat use this information. Much less anyone across the country can go and get some of this data if they're interested in gathering a lot of information. So it's a really neat program, and I encourage you. It's just kind of fun to check out sometime, especially if you're going out on the water. I did notice, and it's similar here, that the air temperature, so it showed 72. I think I did this around 3 o'clock this afternoon. At 35 feet down, the water temperature was 70. So the water temperature right now is really warm on our side of the lake. A lot of times that can be because we've had a lot of winds coming from the northeast, a lot of winds. And so the warmer water is coming across the surface of the water, and it kind of pushes all the warmer water to us, and it sinks down, and then it pushes up on the Michigan side. It pushes up a lot of the colder water. So their water temperatures are probably a little colder on the Michigan side at this point. But right now it's pretty warm. That's kind of rare we get that warm. So I see you have other questions, I believe.
Well, I had a question.
Yeah.
Jim had a question about how is GLOSS funded by NOAA?
It is a, so it's a federally funded program. NOAA is the National Oceanic and Atmospheric Administration. But it is part of their whole system to monitor what's going on in the Great Lakes in general. But yeah, it's a federally funded program.
And I was just wondering, does any of that information suggest problems with the Great Lakes due to climate change?
There are definitely problems to the Great Lakes due to climate change. I didn't include that slide, but we've noticed of surface water temperature over the year. In general, the surface water temperature has raised about 8 degrees in the last 20 years.
Wow.
So, that can really cause a variety of issues. It certainly affects all of our areas. When you have these large systems and the water is heating up, it changes the amount of oxygen in the water, which some fish like higher oxygen, some like lower. So that can change that part. A lot of it changes the level of our water. So water levels have always changed over time. So they'll go, up for a while, then down for a while, then up for a while. But when we don't have ice cover over the entire lake, it can really make a difference. And so now if you've looked at the last 10 years, instead of that kind of rolling up and down, we kind of go up and then down and then up and then down. And that's going to continue and get more and more extreme. And that's really because of climate change. So yeah. We have, I'm kind of continuing. We have some maps that we've been working on where we're doing in-depth mapping of the Lake Michigan harbors. And it's a website you can definitely check out. Ours, part of why we want to do something like this, in the 40s and 50s, when all of the harbors in the Great Lakes were mapped, or all of actually all of our waterways, our rivers, our inland lakes, all of the waterways were mapped. They ignored pretty much all of the harbors in the United States because they thought those systems were dead. And before the Clean Water Act, a lot of them kind of were. There wasn't a lot going on in the waters. So one of our researchers, John Jansen, decided to go in and really map these systems. So once we are finished with the project, and you can go, if you just look at harbor maps at UWM, you can find the website and find out all of the information about how we did it. But once we are finished with the project, which will be over about 10 years, we will have done in-depth mapping of the habitats for all of the harbors from Kenosha all the way up to Algoma, which is right near Door County. So all of the western coast of Lake Michigan in Wisconsin maps will be where we'll have really in-depth information. So that's kind of an exciting project. We do a lot of work with wastewater monitoring for COVID. This is one that we do. We are by and large not the only one. There's a huge program across the country, including in your area. So if you look up Illinois wastewater monitoring, you can kind of find the surveillance system and all of that. So it's a really important tool that we've started using. We've had it for quite a while. More and more have come on since then. We monitor about 12 wastewater treatment facilities, but it's really a way to test everyone at once. So when you look at the start of the pandemic, people were getting tested because they weren't feeling well and had symptoms. So they went and got tested, which means a lot of our information was kind of skewed to being positive in a lot of that information, which is part of why they went to showing numbers of hospitalizations and deaths and those types of things. Now we all have at-home tests that we can do so many at-home tests. And unless people would be really, really, really diligent and tell their local health officials that they had a negative test or a positive test, we would not know that information. So by doing this monitoring through our water treatment facilities, we can sample the entire system at once. So the one actually right outside our door is Jones Island. And in its service area, we can monitor all of the people at once. And it's much less expensive than, focusing and doing all of these individual tests. So what it tells you, so we have in the Milwaukee area, what we're looking at is about 1 million people that are tested on a regular basis because we're looking at our water treatment area. And this is how ours shows up. I did peek a little bit at the Illinois one. It shows up a little differently, but you can find by county, by municipality, if you want, what's going on right in your area and what the 7-day average has been and all that type of thing. It's a really much better way to get a feel for the caseload in a community, because you can see, just like the bacteria we talked about, or in this case, a virus, that does show up in your waste. So we can look at that and determine 10% of the population has evidence of the virus in their system right now, or 4% or 20%. So it helps our communities make a really good choice about what's going on. And this is a nationwide project, like I said. So it is, sometimes it's kind of buried, the information, but you can track down that information as well if you ever want to check it. So we've kind of gone through a lot of stuff, but one of the things in particular that Pat and I, as we were talking, kind of wanted to talk about was plastics in the Great Lakes. There definitely are plastics in our waterways. A lot of the products that are made with in the Great Lakes, and particularly with the Great Lakes water, do have plastics in them. It works a little differently though than in the ocean. So I just wanted to go through a couple of it just to get a little better idea of what's going on in our area. So here's a whole basin right on the left. And just keep in mind kind of the flow of water through the Great Lakes. That whole trip around how does it move throughout the system plays into where the most plastics are found. So this information, a lot of it was from the Alliance for the Great Lakes, which does adopt a beach programs and cleanups pretty regularly. So, you know, most of the beach litter that's collected through those cleanups is all plastic. Most of the bottled water, like I said, bottled water and 100% of the beer brewed in the Great Lakes region contain microplastics in the water or in that product. Most fish have plastic fibers in their system, and obviously produces a lot of CO2 emissions. And then of course, like the pictures show where you have, you know, fish who are struggling, and it's also just messy and no one wants to see that on the beach. So there are about 22 million pounds of plastics. I know it's a depressing thing. Plastics enter the Great Lakes each year. And one of the big changes from the oceans, you know, our plastic that we get may make its way to the ocean, but really in the oceans, you don't know where that plastic came from generally. In the Great Lakes, in Lake Michigan, we do. It came from the people who are living around Lake Michigan. We're not getting it from somewhere else, possibly from Lake Superior, Lake Huron, but that would be about it. So a big change from in the oceans, you'll find larger pieces because of the choppier water that we have and how it gets kind of banged around, because you know, you're looking at water in a bowl versus water in a bathtub. Water in a bowl splashes around a lot more, right? So our plastics stay in the system and they just keep getting broken down and broken down and broken down farther and farther and farther. And so what we're seeing is more than half of the plastics in the Great Lakes are in Lake Michigan. So I was working with someone and we were kind of talking about, well, why would that be the case? And it really comes down to this chart. So looking at it a little bit, you can see, you know, at the top of each column, you have what parameter we're looking at. And then from the largest to the smallest on the bottom. So surface area, Lake Superior has the biggest surface area of the Great Lakes, but we're fairly large as well as far as surface area goes. The volume, Lake Superior, on a fun side note, if you didn't know, Lake Superior, you could take all the water from the other 4 lakes, dump it into Lake Superior and still not fill it up. Lake Superior on its own represents about 10% of the surface fresh water for the world. But it's a huge amount of water. But Lake Michigan has a huge amount of water. Or a huge volume of water. The depth, we're second in depth because it's very, very deep. We have a long shoreline. The last 2 columns, though, are what really kind of gets us. Lake Michigan has the largest population living around it. And look at what happens. Lake Superior has the smallest by far. Milwaukee itself has less than Lake Superior has living around it. More people, even if not intentionally, more people means that more things are able to get into our waterways. And then retention time. Retention time is the average amount of time water stays in a system. So it's a mathematical calculation based on average rainfall and average water that spills over through Sault Ste. Marie and all of those different things. But the retention time for Lake Superior, because it's so big and deep, is about 200 years. You can see it's 191. Lake Michigan is 100 years. And if you look at that and think a little bit about, we have more people who are putting stuff out into the system, and stuff stays around for a really long time. Those are really the reasons why Lake Michigan has so much. It's all of those things kind of play into how our system works. You know, a lot of times, so I do tours of the building, and we'll go through half to 3/4 of the way, and people will go, is everything just bad news? All you've talked about is bad news, invasive species and plastics in our water and all of those things. While yes, there is a lot of bad news in the conversation, all of it has definitely gotten better since the Clean Water Act. Things have vastly improved over the last few decades, but that doesn't mean that we're not dealing with those things from a long time ago. And when you look at that retention time in Lake Michigan, 100 years ago, so in the 1920s and 30s, we had no idea what we should and shouldn't be putting in our waterways. A lot of waterways were still being used as toilets, so we have that kind of long-standing stuff we always have to deal with. And if you have any dredging projects or anything like that, we have a large dredging project that's going to be happening in the next couple of years. That's going to kind of stir up even more stuff from longer ago. So you're always having to deal with those and trying not to add any. So the waters are getting better. They can always get much better, through a lot of work that we do, but it's an uphill challenge. And you can go and look at the currents. Those types of things really involve or inform that information as well. So if the currents are staying in one area, a lot of times water in Lake Michigan goes down along the Michigan coast, kind of swirls around and then comes back up again. So a lot of stuff just kind of churns around and keeps churning in Lake Michigan. Lake Erie. That's actually why Lake Erie has made such a turnaround. Lake Erie used to literally be on fire in the 70s. They are able to turn around really quickly because they're very shallow. The water moves really fast through Lake Erie. And so they can make a change. And within 2 years, that's the retention time for Lake Erie. So you can see those changes much faster. But it's also the reason why we want to protect something like Lake Superior in particular, because anything that happens there is kind of the start of our system. So it's going to flow down, but it also means it's going to be there for a really long time. So what's new with us and what we're doing? I've talked about a lot about the past, talked a lot about a variety of research projects we've got going on. We do have, this is the second fall of our undergraduate program. So now we have incoming freshmen and a lot of transfer students who will be getting their degree in freshwater science. So those students are coming in. Some will be advancing on to graduate studies, but of course, some will just start moving out into the world. We're also really excited. The atmospheric science department, which was in a separate section of the university, just moved here to join with us. In the past, they've actually had struggled finding homes, and they've been in the math department because of all the modeling they do and different things, but we work with them on a regular basis. And you know, what's going on in the atmosphere and the atmospheric sciences and how it connects to the water, in particular over a large body of water like Lake Michigan, really informs what's going on. So we're excited they've joined us. We have lots of new faculty coming in with our policy center and looking at the economics of water. And then we are on the horizon to build a new research vessel. Our Niske, which we love, was a Korean War era vessel. So it was built in 1953 and converted into a science vessel. And it's time for some new technology. So we're working on the fundraising and stuff at this point to create the Maggie Sue, which my slightly informed estimation would be in 3 to 5 years, we'd have that. So before we kind of wrap up, I just want to leave you, again, our former dean, Val Klump, you know, the Great Lakes are key to our wealth, our health, and our way of life. You know, it really is. Living in this area is a really big change for that type of thing. So there's my contact information if you want to ever reach out. I'm happy to answer questions. I will answer more questions here as well. And if I can't, we will connect you with the researcher who actually does the work, because I tell everyone about a lot of the general things and give an overview, but I'm not the scientist doing the actual work. So we'll connect to them as needed and get them involved.
Well, I have to say, Liz, I did not realize that there was so much effort going on for the Great Lakes. I mean, you know, I read and hear a lot of stuff about the oceans and all that. My question to you, though, is, you know, Sierra Club is an advocacy organization. What do you do with your information? I mean, do you do anything to help support initiatives or change or legislative action, or are you informing people? Like, how does your education, other than informing the people in the area, do anything to change things?
So some of, well, first we are, because we're a public higher education institute, we are not an advocacy organization. In fact, sometimes because we are a state public institution, we are kind of not allowed to be, we have to be unbiased. But that being said, many of our researchers and the Center for Water Policy itself does go and talk to, whether that's on a federal level or a state level, or in the region, to talk about, you know, what we're seeing and things like, I know one of our researchers was very involved in the microbead ban that went in the state of Wisconsin. We're on a lot of national groups to try and make decisions on a variety of things. So we try to share the information. In my role, I try to really share everything we have, just so the people who live in this area have an understanding of kind of how their system works. It's funny, when I was getting ready to start the formal program here, I thought I'd have to talk about all of these really high level, you know, different chemicals that are in the water or different systems. I spend most of my time talking about watersheds. Because if you don't understand how the system works in a watershed, how, water is coming from here and it flows down here, how do you understand that what you drop on the ground there is making a difference in our water? So I work to help our citizens in the area know more about what's going on.
And how do you do that? Are there newsletters? Other than presentations like this, how do you communicate with people?
I do a lot of presentations. We do tours. I do professional development for teachers. I do a small number of field trips and stuff for schools, but I am a full-time department of one. So I decided to shift my efforts so that I could help teachers understand how to talk to their students about what's going on in water. And then I do some work at a variety of events and that type of thing. I help our researchers when they go and talk about what's going on with their science. All federal grants require that they have some type of outreach to stakeholders, and some of them do a wonderful job and they have the capacity to cover that. Some I kind of consult on activities that they could do, and some I do it for them because they don't have the opportunity to. And then my last project, which I really enjoy, I work with our students and help them understand how to communicate science and help them practice that. So they can kind of go out to schools or to community groups and talk about their science. And while it informs the public in general, it's really important for them to get those skills so they know how to, so they're not skipping and understanding how important it is for people to understand what's going on.
Right.
Mhm.
Well, there was a comment in the chat. I just want to say one of the registrants said many thanks to Liz for the presentation and the Sierra Club members who helped coordinate it. So thank you. If anybody else would like to put something in the chat, please do so. Jim, were you going to say something?
Yeah, then a call came in, I'm sorry. Yeah, there's so much in this presentation. Thank you very much. I just wanted to say, if anyone wanted to ask a question, they can raise their virtual hand too, or, put it in the chat. I did have a question going way back. Let's see.
I can bring my presentation back up.
Right. No, that won't be necessary. It had to do with, you talked about aquaculture.
Aquaculture.
Yeah, right. And raising fish. Now, I know that commercially, a lot of times, everyone wants to get like omega-3 fatty acids, because of that's found in like fish that are caught in nature. But of course, there's catfish farms and stuff commercially done. They end up feeding them feed corn. I was wondering what sort of nutrition do these aquaculture get?
So they are developing new types of feed for them. So it kind of changes some. They grow some in small scale, like plankton and different things. So they do some of that. It's generally not just feed corn, but I couldn't tell you exactly the work. I can though put in the chat the website of the researcher who focuses on that. Her name is Dongfang Deng. And she would have a lot of information about that. I just want to find her information. And And then, that gives you a chance to really learn more in depth to answer that question.
Also,
Mhm.
I mean, this is kind of crazy, but is there any way that these zebra mussels can get rid of the microplastics in the lake? I mean, they're filtering the water anyway.
Right.
So,
So they do get a lot of toxins in their system. But I haven't heard, I know who I can ask, but I haven't heard anyone mention that they've specifically focused on microplastics with them. There has been a lot of work, kind of more what fish are trying to eat the mussels, because none of our native, well, a couple now are starting to, but most of our native fish don't eat them. So now you're getting it kind of more from that way. We do have, I was just hearing about a graduate student who was working on whether or not they are playing a role in what toxins or pollutions and stuff are in the water. So there may be someone who's working on it. One of our graduate students might have started a project on that.
I mean, I've heard that it's, microplastics is just as big a problem as climate change. I mean, and the two are absolutely devastating. So we got to maybe start thinking outside the box and get a little crazy with it. Maybe, I don't know.
And that's part of the researcher, when he brought up like the Asian carp, what the researcher, part of his concern, because he's seen it happen before, is that we spend a lot of money focusing on keeping them out of the Great Lakes, when maybe that's not, maybe our money, because it's kind of a low risk of them taking over Lake Michigan, maybe our money is better spent trying to solve some other issues like microplastics in the water.
Right. Okay. Well, are there any more questions from anybody? Comments? I mean, a bunch of people are
Liz,
like,
you mentioned about
thank you.
tours, and I was wondering, can we go on a tour?
Absolutely. You can
what would we see?
So our tours are about 90 minutes generally, and we walk through and I talk to you about the research that's going on. And you get a chance to look in our labs, and we ask questions of anyone who we're walking past and can bug. So if you've got, I do general public tours on the third Thursday of the month. It's a really, if you've only got a couple people, that's the way to go. But if you think a group of 10, 12 or more of you would be interested, then you can just reach out and we'll set up a time for when it works. We can generally do about 50 total at one time. We just split you up into smaller groups, but definitely we come up and talk about a lot of things. Unfortunately, one of the things that everyone wants to see are our fish themselves, but because all of you have bacteria, and so do I, it can be a big challenge. So we generally don't for tours, but we take a peek into all the spaces we can.
So we would just go to the University of Wisconsin-Milwaukee website, and there would be a place we could follow, links to follow to find out about the general tour or more specific.
Yeah, I can include that in that link as well, quick, if you want.
Sure.
But yeah, awesome. We can definitely set up a group tour if you guys, are really interested and want to find a time. I'm happy to do it.
I am saving this chat too, so anyone that wants it, please let me know. And send us an email, NWC. I'll put, you know what? I forgot to put our email in.
Another opportunity, if you want to come up, we have we have many partners in the building, and one of our partners is kind of overseeing a bunch of us, and we host a festival right on the street in front of our building. It's called Harborfest. And so it's a street festival with lots of good food vendors, and many of the water organizations in the area have like little booths. We will have an open house where many of our researchers and students will have like hands-on demonstration type things. The Milwaukee Riverkeeper are hosting a boat parade. So they make these giant floats on boats and do a parade. There's boat tours of the harbor, and an organization here called River Edge. They raise baby sturgeon for the Wisconsin DNR. And so they raise them all year long, and they'll be releasing them on that day. So if you go ahead of time, you can sign up and release your own little baby sturgeon. They're like that big. They're super cute. So all of that's going on September 25th. So if you want to come up, it's a Sunday from 11 to 4. We have a lot of fun.
They could do the solar tour the day before and then do that and release
There you
baby
go.
sturgeons. Awesome. All right. Well, thank you very much again. And thank you everybody for hanging around. There's still 15 participants here. We started out with 18. So thank you very much. And like I said, this has been recorded and will be available on YouTube at some point, and you'll be notified by email, and I think through Facebook as well, and maybe Instagram, but definitely by mail. That's correct, right, Allison? I will send the link is what Allison.
Yes, I'll send it to everyone registered. Yeah, thank you.
Great. Well, thank you, Allison. And so if there's nothing else,